All right, thanks for watching. And today I would like to do a problem using the sum law for cosine and sine. So here's the problem. Suppose you have an angle alpha, and you know that tangent of that angle equals 1/2. And moreover, that angle is between pi and 3π/2. Okay. Before we move on, let's draw a picture of this quadrant because it'll be very important in our problem. So again, if you have the unit circle, what this is saying is that the angle is between pi and 3π/2. So it's somewhere here. Alpha is somewhere here. In particular, we'll need this later. Cosine and sine of that angle is negative. So that's on the one hand. Suppose tangent of alpha equals 1/2. And moreover, we also know another angle beta. So, and we know that cosine of beta equals to 3/5. And there's no debate about this. And beta is between 3π/2 and 2π. So what this means is, in our circle, beta is in the fourth quadrant. So beta is here, and in particular, well, cosine of beta is positive, which we have here, and we'll see sine of beta is negative. So again, we have two angles, alpha, tangent of alpha equals 1/2, and cosine of beta equals 3/5. And here are the questions. The first problem is find cosine of alpha plus beta. And for this, there is a stupid way of doing it, which would be to find alpha, find beta, add them, and do cosine of that. No, no, no. If you see cosine of alpha plus beta, you have to use the sum law of cosines, which just says the following: cosine of alpha plus beta equals cosine of alpha cosine of beta minus sine of alpha sine of beta. Now, on the exam, this formula will be given, but in case you do want to learn this, the way I remember this is as follows, because if you know cosine of 2x, that is cosine squared of x minus sine squared of x, which we'll learn soon, but that's just cosine of x minus sine of x sine of x. You see, so cosine minus sine sine. And same thing here, you see cosine alpha cosine beta minus sine alpha sine beta. Okay, and again, it's not important, it's just a mnemonic, but what is this saying? This is saying that we have to find four things: cosine of alpha, cosine of beta, sine of alpha, sine of beta. And remember, we had a couple of things that we knew. We know tangent of alpha, which is 1/2. And we also know cosine of beta, which is 3/5. Okay, so let's do every step first, everything step by step. So first, let's find cosine of alpha. Now, we know tangent, and the question is there a way to relate tangent with cosine? Yes and no. So we can't really relate tangent with cosine without talking about sine, but there is this other formula that simply says 1 plus tangent squared. It's one of the fundamental formulas that says 1 plus tangent squared of alpha equals secant squared. And we'll be able to solve for cosine here because secant is just 1 over cosine. So what does that give us? It gives us secant squared of alpha is 1 plus tangent squared. So 1 plus 1/2 squared, and this becomes 1 plus 1/4, and that's 5/4. So secant squared is 5/4, but remember secant is 1 over cosine. So 1 over cosine squared equals 5/4. So again, 1 over cosine squared equals 5/4. And in particular, to get cosine squared, you take reciprocals. So cosine squared of alpha becomes 4/5. What is that telling us? It tells us that cosine of alpha is either plus or minus square root of 4/5, and that's plus or minus 2 over square root of 5. Now here's a big question. Is it plus or is it minus? Usually difficult, but remember at the beginning of the problem, if you go all the way up, we drew our trig circle, which is very useful because what we want to know, we knew tangent, now we want to know cosine of alpha. Well, remember alpha is in this region, so cosine of alpha must be negative. So the question is it plus square root of 4 over 5 or minus square root of 4 over 5? Well, in this region, cosine is negative. So going back, it becomes negative to square root of 5. So this is very typical. You're always wondering what is the sign. In order to figure out the sign, you have to use the trig circle. Now, 2 over square root minus 2 over square root of 5, it's completely fine, but in order to make your algebra easier, what I highly recommend is getting rid of the square root of 5. And the way you rationalize the denominator here is you multiply top and bottom by square root of 5. And last but not least, you have cosine of alpha is minus 2 square root of 5 over 5. So that's one thing. We finally figured out cosine of alpha. And I don't know why it became like that, but we found cosine of alpha. And then, well, what is cosine of beta? Well, luckily it's already given to us. Okay. So again, cosine of alpha was something minus 2 over square root of 5. Cosine beta is 3/5. And now the question is, what is sine of alpha? So let's move on. Well, we know cosine. We want to figure out sine. Well, there's this quintessential identity that relates cosine and sine, which is just a Pythagorean theorem. Cosine squared plus sine squared equals 1. So sine squared of alpha is 1 minus cosine squared of alpha. And that becomes 1 minus. You could use this. It turns out for this simplification, the first thing is better, because if you square minus 2 over square root of 5, you just get 4/5. So 1 minus 4/5. And again, careful not to cancel out those two signs. And you get 1/5, which tells you, again, sine squared equals 1/5. So sine is again plus or minus square root of 1/5. Again, is it plus or is it minus? Let's go back to a unit circle. Okay. Well, again, alpha is in this region. And in this case, remember, sine is the y-coordinate. So sine is negative. So the answer is again negative. All right, very good. And then, so what you're left with is minus 1 over square root of 5. But again, rationalize the denominator by multiplying by square root of 5. And I think you're left with minus square root of 5 times square root of 5 squared, which is minus square root of 5 over 5. Great. So we're actually 3/4 done. I know this is very long, but once you know that, you also know the other formulas. So we found cosine of alpha, cosine of beta, sine of alpha, and lastly, let's find sine of beta, but it's easy because we already know cosine of beta. So again, what do we know? We know cosine of beta. I believe it was 3/5. Yeah. All right, and now let's just use cosine scoops. Technical difficulties. Now, let's just use cosine squared plus sine squared equals 1. So again, sine squared is 1 minus cosine squared. Okay, and that becomes 1 minus 3/5 squared. And that's 1 minus 9 over 25. Okay, and that becomes 25 minus 9 over 25. And that is 16 over 25, which is actually nice. It simplifies. So then what we get, sine squared of beta is 16 over 25. So again, sine of beta is plus or minus square root of 16 over 25. Again, is it plus, is it minus? Well, let's again check our unit circle. So let's go up again. Well, now remember beta is in this region, so sine of beta, my apologies. So sine of beta is, this time it's again negative. So sine of beta is here. So it's negative, but careful, cosine is positive because we are in this region. So in particular, the answer is again negative. Okay. So it becomes negative square root of 16 over 25, and that becomes negative 4/5. Good. So now we have all the components and we just need to solve the problem. So remember, what did we have? Cosine of alpha plus beta, that is cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. And really, to prevent any algebra mistakes, I would write down explicitly cosine of alpha, cosine of beta, sine of alpha, and sine of beta. I promise you, if you do not do this, you're very likely to make an algebra mistake. So protect yourself from any mistakes. So what did we have? Cosine of alpha, I believe that was minus, I can double check. Cosine of alpha was minus 2 square root of 5 over 5. And then sine of alpha was minus square root of 5 over 5. So let's fill this out. Minus 2 square root of 5 over 5. And then minus square root of 5 over 5. And then cosine of beta, I believe that was 3/5. You see here. And we found sine of beta was minus 4/5. All right, so now let's plug this all in. Cosine of alpha is minus 2 square root of 5 over 5. And cosine of beta is 3 over 5. And then minus square root of 5 over 5 times minus 4/5. And unfortunately, in this problem, you see how long it already is. You have to be very patient. because otherwise if you make a small algebra mistake, it ruins your whole problem. But again, we are almost done with this course. So this becomes minus 6 square root of 5 over 25. And careful, 3 minuses, which becomes minus 4 square root of 5 over 25. And that becomes minus 10 square root of 5 over 25. But remember, 10 over 25, that's just 2/5. So minus 2 square root of 5 over 5. And this is finally the answer to the problem. All right, that was cosine. And well, we still have sine and tangent, but the good news is we already found everything that we wanted. So how about the next question? Sine of alpha plus beta. Well, remember the formula, it becomes sine of alpha cosine of beta plus cosine of alpha sine of beta. So you flip it, and again, the way I memorize it is just, we do have the formula for sine of 2x. That's 2 sine of x cosine of x, which is really sine of x cosine of x plus cosine of x sine of x. So you see sine of alpha cosine beta plus cosine alpha sine of beta. Again, provided you know this formula, which might be later in the course, but personally, this helps me. But again, the good news is we already know all our values. So again, just to recap, what was sine of alpha? I believe that was, let me double check. Sine of alpha was minus square root of 5 over 5. Cosine of beta, that's the stuff that was given to us, 3/5. Cosine of alpha, I believe minus 2 square root of 5 over 5. And sine of beta, that was 4/5, or I think minus 4/5. Everything is negative. So again, you plug that in. So sine of alpha cosine of beta. Maybe I can make this a bit smaller. Guess not. Yeah, much better. Okay. Then just to plug that in, so this becomes minus square root of 5 over 5 times cosine of beta, so 3/5, plus cosine of alpha minus 2 square root of 5 over 5 times minus 4/5. And again, let's simplify this. So this becomes, one second. Yes, okay. This becomes minus 3 square root of 5 over 25. And again, minus minus plus 8 square root of 5 over 25. And then this becomes 5 square root of 5 over 25. And that just becomes square root of 5 over 5. So that's the answer for sine of beta. It's a good sign. Last but not least, what about tangent? What about tangent? Well, you could use this weird formula for tangent of alpha plus beta. But look, you already have sine and cosine. So just take the ratio. Because tangent is sine of alpha plus beta over cosine of alpha plus beta. And what that gives us is the following. We had, so sine, I believe, was the stuff we just calculated, square root of 5 over 5. Cosine was minus 2, square root of 5 over 5. And remember, when you're dividing by a fraction, you have to flip it. So square root of 5 over 5 times minus 5 over 2 square root of 5. You see, this you flip. And this cancels out. This cancels out. It turns out you're left with -1/2. So that is the answer for tangent. Wonderful. So in this problem, we're basically done. We found sine, cosine, and tangent of the sum. Just one more little thing, just for extra practice. Notice here the answers were surprisingly simple, but in general, they can get more complicated. And I believe there was a problem that where the answer is something like that: 3/5 minus 2 square root of 5 over 1 plus 6 square root, sorry, 2 square root of 2, I believe. Over 6 square root of 2 over 5. And the question is, how would you simplify that? Well, for this, what you should do is, first of all, put everything under a common denominator. So here under 5, so 3 minus 2 square root of 2 times 5 over 5 over, again, 5 plus 6 square root of 2 over 5. And again, you flip it as usual. So this becomes 3 minus 10 square root of 2 over 5 times 5 over, again, lots of 5s, high 5, plus 6 square root of 2. Then the 5s cancel out here, and you get, let's see, 3 minus 10 square root of 2 over 5 plus 6 square root of 2. Now, remember, we don't like square roots on the denominator, so what you should do in this problem is multiply by the conjugate. So multiply top and bottom by minus 5 minus 6 square root of 2 and 5 minus 6 square root of 2, because you get a simplification. So for the top, you FOIL it out. 3 minus 10 square root of 2 times 5 minus 6 square root of 2. And for the bottom, you use a squared minus b squared. So it's 5 squared minus 6 square root of 2 squared. All right, so calculate this. So again, FOIL this out. So it's 15 minus 18 square root of 2 minus 50 square root of 2, and then plus 60 times 2 over 25 minus, so 6 squared, 36 times 2. And again, calculate this. So this is 15, this is 120. So 15 plus 120 is 135. 8 minus 18 minus 50, that's 68 square root of 2. And then you get 25 minus 72, which I believe it's 47, minus 47. So 135 minus 68 square root of 2 over minus 47. And because you have a minus, you just divide this by minus 1. And I believe in the end, you just get 68 square root of 2 minus 135 over 47. So this is how you would simplify more complicated expressions with sine and cosine, which I'm sure you will see at some point in your homework or your math career. All right, I hope you like this. If you want to see more math, please make sure to subscribe to my channel. Thank you very much.